Today is a historical event. Um, I am very excited by this gathering of intelligence. So, for my presentation, I wanted to basically tell a story. Um, I I will be mixing a lot of different topics. I'll talk about AI. I'll talk about finance. I'll talk about social science, all within half an hour. So I want to do that as a story, a story that, on occasions, I will use rhetorical exaggerations, so you can see what I mean. And this is my first one. If I look at engineering in the 20th century, I would summarize it with three aspects of it. First, no data, small data, okay? Lots of equations, and dealing with the physical. And the best example of that is going to the moon, right? I think that's one of the big accomplishments of 20th century engineering. And it does satisfy that. I mean, what data was there? Well, gravity, 9.81, that's it. That was the one data point, right? Lots of equations, and then then you move through space, and then you land there. Okay, so that's the big achievement of the 20. Now, how is the 21st century shaping up? We're at the beginning of it. And I would argue that is very different. First, there's lots of data. Then I would argue there are no equations. I'm a mathematician, okay? I have the license to say this. This is the exaggeration that no one is going to blame me for that. So lots of data, no equations, and we're not so much dealing with the physical anymore. I want to say that we deal with mental space. You say, how can I say that? We're talking about climate. Climate is real. Of course, again, rhetorical exaggerations. We all talk about the weather, what, a year from now? A decade from now? Let me call that mental space, okay? But I don't have to go to climate yet. I will end with climate, don't worry about this. But I want to make a bit of a more general talk. One of the, if you look at innovation, lots of data, no equations, mental environment, that's Facebook, right? So I think that's going to be a little bit of what I'm talking about. Now, let me do a personal introspection. This is the first paper that we wrote at the Risk Lab, which we did in 1996. That was a paper that fits this model. We had no data. We had lots of equations. I hardly ever have written a paper with so many equations. But it was on a mental environment. We're dealing with financial risk. Okay. Now, the last thing we have done is something which is completely different. Let me show you. This is a picture. I have to say there are two people who are very critical. What I'm talking about today. Alex Sokolov is there, and A.V. Wang is there. I'm going to mention their name, when I'm on stage. That's a picture of the Premier of the province of Ontario. It's one of our last papers. Okay. And what he's holding in his hand is a piece of work we did. I should say Alec did. Okay. This is our COVID projections. During the pandemic, we were giving, roughly on a weekly basis, the province of Ontario with some projections of what might happen if they did certain things. That's something that we did. We wrote a paper about that, and Alec was very much behind that. And so that was our COVID report. And if I look at that, well, we had a certain amount of data. We had no equations, and we were dealing with the physical environment. So this is somehow our evolution over all of these years, where we have produced a lot of different papers, and these are really the exceptions to our activity, because most, as you know, when you do research, most of what you do is a failure, right? So these are the exceptions. This is when we actually got something done. So we're reading a lot of papers over the years, some results. They've been evolving into this type of mode that I'm telling you, but perhaps something else that I should mention is that in addition to this, as this is very important for us, is one of the things that we did is we also launched, I launched a company, an investment company, that was in about 20 years, we did about $3 billion of investments of into about 50 different hedge funds. This is very important because for us, finance is very important. It is the way we see the world. I've been doing that for a long time. So when I talk about 21st century engineering, with a financial perspective, with our COVID experience, providing information to the government, what came out of all of that? Well, what came out of all of that is a type of renaissance that I consider this event to be, at least for me, very iconic about the new world to come. So, personal experience, what we did after all of this is we regrouped our efforts and we started to go ahead of what we thought the next challenges might be. And we gave it a context of the 17 Sustainable Development Goals of the United Nations. And I believe that a lot of these things are going to be shaping what the world is going to be about. But going back to finance, I like to mention this example. Talk about our first result. This is an article from the New York Times from the year 1990. I call this the beginning of the social fintech. There was no tech, social fin. Okay, we'll add the tech later. This was a very surprising decision by the Harvard University Endowment Fund. For those of you who are my age or older, you would remember that in 1990, all we were talking about when it came to investments was apartheid. It was the investment from South Africa. Okay, and then suddenly, out of nowhere, Harvard University and City University of New York came out with a decision to divest from their tobacco stocks. That was surprising. Tobacco stocks. Tobacco stocks were the best investment you could do around those times. There was a sentence coined by one of the hedge funds at the time: is you make it for a penny, you sell it for $1. There's no better investment than that. And then suddenly Harvard University comes out and says, no, we're not going to do that. Why? Well, these were their stated reasons. Basically, so we're investing in companies that kill their customers. Doesn't seem like a good trade. Okay, so why is this important? For me, this is important because perhaps you can say it was the beginning of responsible investing. Sure, but for me, there's something more interesting here happening, which is this was an investment decision that takes into account a new type of ingredient, a new element, which is what I believe is we're seeing more and more of these days, which is the inclusion of social considerations when you do something, not just investing, when you do other things. Okay? And if I try to put this into the perspective of how we do things today, I will show you this. This is something which is not done by me, it's done by him, Alex Sokolov, his company does this. And this is very interesting because what this is an application of large language models, where if you look at what our Harvard did, let me just go back, okay? How can you codify this from a technology perspective? Of course, this technology did not exist. ChatGPT did not exist in 1990. But is this something that you could do with large language models? The answer is yes, you can. Yes, you can. In fact, you can do much, much more than that. You can start to introduce lots of considerations into making decisions when it comes to investing. And this thing that Alec did is a very good example of that. You can take as your data whatever you want, New York Times, Reddit, your choice. No equations, you don't need them. Large language models, let me say it, they don't need equations. And what you're dealing with is you're dealing with a new space, you're dealing with a mental space, which is you're trying to understand what this company does. And you can see this through time even, okay? So this aims at providing a technology support to the investment process. Again, I'm going to adopt an investment focused perspective because that's who we are. That's what we've been doing over all this time, okay? And in fact, if I make a retrospective of how finance have moved over the last 100 years, at the beginning, about 100 years ago, all the data you could do fit in a piece of paper. Accounting information is all you needed, which was a good idea because there were no computers back then. The first computers, coincidentally, were done around the time that portfolio theory was built. That was perhaps not a coincidence, and that's why time series analysis became important. You suddenly had computers that could do that, okay? Before 1950, there were no petaflops. There were no flops, okay? There were pencil and paper, right? So that signified a change. And then, of course, by the year 2000, everybody had a PC in their home, and I carry probably 3 computers with me at all times. And then, of course, numerical methods, and then this big explosion of quantitative methods happened. But that's all coming to an end because, again, the reflection that what is making a difference now is completely different. The introduction of social media as your fundamental data source, or documents, or filing, or disclosure statements, or things, and that's how we'll get to weather eventually. All of that is changing the way we do what we do. And from that perspective, I would argue that metadata is what is going to be changing what we do. We're used to a situation still today, and in a lot of the classes we teach, where databases mean numbers. That's no longer the case. Textual data is just as important, perhaps more. That's where ChatGPT lives. But now, all of this is augmented very quickly by sensor data, and very soon by images, satellite, video, etc. And finance, again, I'll talk about finance, is going to be driven by this. Let me give you, I don't know if you know this, but you know what a carbon trade is, I assume. Do you know what a carbon trade is? So when you do a carbon trade, let's say you plant a forest, and that forest has a certain amount of carbon capture per year, then you get carbon credits for that. To do that, to calculate the carbon credits, the amount of data that goes into that is, I'll exaggerate, you need to know exactly how many leaves those trees have. You need to know the amount of humidity that the trees have. You need to, that amount of information is tremendous. And how can you do that? Well, right now it's being done manually. Think of the Harvard University decision, manually by consulting companies and auditing companies. But if you can run an army of drones over the forest, you can very quickly get that information, and then that gets codified, and then that gives you a very accurate picture of the carbon capture characteristics of that forest. This is the type of finance we're doing. And if you can now project, this is happening now. If you can look at the example of what Harvard University did with the tobacco companies, put that into today's world, equipped with all of the artificial intelligence and ability to analyze data that we have, that gives you that what's happening in the world of finance and trading is a very different situation. I have here an example which will tell you how deep this can go. This is you probably know this. There's a very if I had more time, I'll play a game with you. I know the answer because I do this very often. Okay, they said I have a game here where I give you a choice. Okay, choice A is you make money for sure, and choice B is, well, maybe you make a little bit more money, or maybe you lose. Maybe you don't make any money. And most people, I mean, I'm not going to ask you to raise. I already know the answer. Okay, 10% of you are going to choose choice B. 90% of you are going to choose A. That's how it works. Okay, and the people who choose B is because they like to be contrarians and they just disagree with anything. That's just the number. I do this very often, right? But then if I give you The opposite game, you're going to lose money for sure, or there's a chance that you're saved. Then again, 90% of you will choose B, and only about 10% of you choose A. This is interesting at many different levels. First of all, humans will make that decision. Machines will probably make a different one. That's number one. Okay, there's something human in this decision. Our brain is a very good risk management system. Hmm? That's why we're surviving, right, as humans, all these years. But another is that there's a social element to this. There's applications of this to lots of different social situations where we run away from danger. But perhaps more interesting is that I can turn this into a market. Because if indeed some of people have different choices, then I can create a market. I stay in the middle, I become a broker, change the numbers slightly, and then I'll make money every time you trade. Yeah? Yeah, that's what market makers do in finance, by the way. Okay? Except in this case, I'm using social arbitrage to make some money, and then I have a business. Okay? So I use your bias to trade you away, and then I'll make money. Now, this is interesting because if you think about this going forward and you're equipped with good technology, you can take this to situations where things are not so clear, and then you start trading on sentiment. And sentiment analysis is something very, very important. And we can analyze that very well because that's what large language models can do for us, right? And when it comes to climate, there's a very important aspect of climate, which is climate trading, in particular carbon credits, and the ability or the will that people have to pay for certain things. How many of you have neutralized your airline ticket when you fly? Right. I do it. It's a company policy. University of Toronto. We need to neutralize, but it's a decision. It's a personal decision, right? So a lot of these things are becoming more social, and this gives rise to what I call the beginning of the social fintech, where you can start to create financial systems that are built on social issues. And this is just one example. I want to put this in a more generic context, and I want to go back to Hammurabi, who was just around there to the left, right? About 4,000 years ago. He was, in his Code of Hammurabi, he was one of the first examples of insurance trading. That's how the insurance industry was created about 4,000 years ago, okay? And what is a modern day analog of that? Well, for me, it's Article 2.1c of the Paris Accord. Article 2.1c of the Paris Accord says that you're going to use financial systems to, as a pathway towards low greenhouse gas emissions and climate resilient development. So it's the same thing 4,000 years later, okay? And the advantage we have is that Hammurabi, well, they didn't need this for the insurance business back then, but to be able to do this, we need to quantify things that are very hard to quantify. But this is the area where technology can be used. So how can we do that? All right, so how can we do that? Now I want to talk about portfolio construction. This is one of the other results that we have done. This is, I'll just go through this very, very quickly. There is a way to use machine learning and artificial intelligence to make portfolio constructions decisions. Okay, this is something that we've been doing a lot. This is part of a paper that we have again with Alex Sokolov, and this leads to I'm not going to discuss this, but let me just tell you that there is a way to do hierarchical risk parity when it comes to this. Risk parity, for those of you who don't know what it is when you are going to make an investment, you invest less in the more risky things. Okay? It's a very simple description of that. But to be able to make this work, there's a very important aspect that I want to highlight here, which is the concept of relationships. when risk appears as a consequence of relationships, things which are related to each other, and you put them together, they end up giving you, more risk. And by the way, I'm not talking about causal. That's for next year. Okay. Next year's talk we'll talk about that. This year's talk is all about um, coincidence and relationships. Okay. And once you build an investment model like that, then you can do two things. First is what everybody expects you can do, which is to have a portfolio allocation strategy that has better returns. I'm not interested in this. This is the one where I'm interested in. It's part of the index replication, but for me, this has a very important application, which is to the creation of benchmarks. Once you understand relationships, you can create benchmarks. So we did that in the context of portfolio construction, but I'm less interested in that as I am interested in understanding relationships when it comes to climate. Okay, so what is this doing? This is something that we built to do. The S&P 500 is an index. The index has certain properties. What is is what best describes the joint movement of stocks. That's not relevant today because I want to focus on climate. So if I focus on climate, let me move to what climate is. And climate is a wonderful risk management system. It's very simple because it's only one risk factor: emissions. You may be surprised to hear me say it's a simple, one risk factor: emissions. You want something more complicated? Look at biodiversity. That's much more complicated. So at least climate is based on one factor, it's emissions. And one of my favorite graphs or tables for emissions is this one. This is part of a whole school of analyzing emissions. And this is, you may have seen a table like this. This lists the countries by their emission volume, CO2 emissions, okay? Now you can see China is the biggest emitter, 10 billion tons. And then United States, and then you may argue, well, of course, that's because China is a very big country. So then there's another table that is done, which is the emissions per capita. Okay, and then let me ask you a question: which one is right? Emissions per capita or absolute emissions? Neither is right. Neither is right. Okay, because then you have a country that has, as you know, emissions is not related to people only. It's a lot of that, we heard it this morning, is linked to agriculture, for example. So what is the right element? What is the right way to do a comparison when it comes to analyzing countries' emissions? So one of the things that you can do is you can do what's called emission benchmarking. Emission benchmarking is you can try to analyze what are emissions due to. In other words, if I go back to my previous, to assume that emissions are linked to a single risk factor model is not right. They are probably a combination of different things. And if they are a combination of different things, we know that you cannot divide by any one of them. You have to do something different, okay? So what we did is try to figure out what is the right factor analysis of, again, it's going back to relation. It's not causal, it's just factor analysis. So if you want to understand emission benchmarking, you want to understand the factor analysis of that, what we came up with is that there are a number of conditions, so which population is one, but there's others. There's GDP, there's surface area, urban population, that affect emissions. So it's only from that perspective you can understand emissions. But if you do that, then you can do something very interesting, which is you can do what I call emission chromodynamics. You can understand how countries now have a benchmark. A country based on their economic properties has a certain emissions budget, so to speak. And then you can see if you're above or below it. And then you can see if you've been above or below it for a while. Now, for example, this country, I'm not going to mention these countries because this is something, I really wanted to talk about this, and I am, this model is not finished yet. It's just a preview, but it's something very interesting because in this country, for example, here, we can see that this country is moving from brown to green. That's why I call it emission chromodynamics. You move from one color to another, right? And you can say that these are the countries doing the opposite, going from green to brown. But now this is rooted on the right benchmark, so to speak. It is not per capita, it's not per surface area, it's not per GDP, it's per everything that contributes to emissions. And only from that perspective we can understand how we can actually compare these things. Okay, this is something, by the way, this is not linear regression. Linear regression does not explain it. Okay, it's far more complicated than that. It's understanding relationships the way AI does the understanding of relationships. Maybe not as advanced as large language models yet, but it is in that realm of understanding how relationships work. Okay, and on that note, I want to end by saying that this thing that we did here is done by a whole bunch of people. This is the team, and that's the end of my story. The causal, we'll save that for next year. Okay, thank you very much.